Alright, so as you are working through lesson 2 of unit 2, in the problems you've not completed, please make sure you complete the problems before watching the video. If you're stuck on a problem and need some additional information, then watch the video to the point where you have enough information, turn it off, complete the problem, and then turn the video back on to verify that you have completed the problem correctly. So problem number 2, they're asking to solve for AC and BC. I'm going to call this X and Y. And if I shade the two sides at a 20-degree angle, X would be the opposite side, the 6 will be the hypotenuse, and the Y side would be the adjacent side. So if I would start with the X side using the hypotenuse, this would be a sine problem. The sine of theta is equal to the opposite side over the hypotenuse. So if I put in the angle measurement 20 degrees, the opposite side is X, the hypotenuse is 6. Anytime we are solving for length, we always cross multiply. At least that's the method that I prefer to use. So we cross multiply, and we get 6 times sine of 20 degrees is equal to X. So if I put my calculator again, always check the tangent 45, make sure you get the answer 1. So 6 times the sine of 20 degrees is approximately 2.052. For BC, you have 2 options. One would be to do another trig problem using the adjacent of the hypotenuse, which is cosine, or because you have 2 sides of the triangle now, you have the 6 and X is 2.052, you can also use the Pythagorean theorem. Since this unit is about trigonometry, I'm going to go ahead and do the problem as a trig problem. So cosine of theta is equal to the adjacent side over the hypotenuse. I prefer that we use the hypotenuse here and not the opposite side, the 2.052, because the 6 is the exact answer, where the 2.052 is an approximation. So replacing the numbers, so cosine of 20 degrees is equal to y over 6. Again, we're going to cross multiply. There's going to be 6 times the cosine of 20 degrees is equal to y times 1, which is y. And if you put that in the calculator, what we end up with is 5.638. So problem 3, they're asking for the height. So we're given here, if I shade 2 sides of the angle, the height would be the opposite side. The hypotenuse is AC, and then the 250 would be the adjacent side. So in this problem, we are solving again for the height using the adjacent sides. This is tangent. So tangent of my angle is equal to the opposite side over the adjacent side. So I'm going to plug in the numbers. Tangent of 73 degrees is equal to h over 250. Again, anytime we are solving for length, my preferred method will be cross multiplication. So 250 times the tangent of 73 degrees is equal to 1 times h, which is h. So 250 times the tangent of 73 degrees is approximately 817.713 meters. Alright, so in problem 3 as well as 4, one of the things that will create at least a level of inaccuracy in our answer is the fact that the person is looking up to create this angle. There is a distance from the person's eyes down to the ground that's not being included. in the answers. Keep in mind these are approximations. So problem number 4 in the largest masonry building in the world is in Philadelphia. Roberto is standing 1,300 feet from the building, looking up at an angle of 23 degrees to see the top. And again, we're looking for the height. Keep in mind that the height does not include the distance from the person's eyes to the ground. So the answer is going to be off by at least 4.5, 5 feet or more. So if I shade the two sides of the angle, the height will be the opposite side. And the unmarked side is the hypotenuse, and the 1,300 is the adjacent. Again, using the opposite adjacents, we're looking at a tangent problem. The tangent of theta is equal to opposite over adjacent. We plug in our numbers. The tangent of 23 degrees is equal to h over 1,300. Again, third method here, again, length is cross multiplication, so it's 1,300 times the tangent of 23 degrees is equal to 1 times h, which is h. So 1,300 times the tangent of 23 degrees is 551.817 feet. Now, the one thing that's being asked here in problem 5 is that they're actually giving you the exact answers to both problems. And you'll notice that the answers are our answers and the actual answers are off. So why don't the answers match up? Why don't the calculations give us the same answers? So I'll turn the video off, write out your answers, and then turn the video back on when you're ready to continue. So there could be a lot of reasons why the answers are off. One thing I noticed in both problems 3 and 4 is the fact that the angle measurements and the distance were all really nice numbers. So in other words, 23 degrees was like 23.5 degrees, 23.7 degrees. So the chance of someone standing exactly 1,300 feet from a particular building, looking straight up at the top of it and be exactly 23 degrees, probably not going to be exact. If you think about problem number 3, for example, and I'm going to change the screen for a moment. Problem 3, the numbers were 73 degrees and 250. So if we would take the 250, it was a tangent of 73 degrees, and that was our 817.713 answer. And so what happens if, let's say, for example, we're off by 1 degree in either direction? Again, I'm trying to prove a point here about how much does an actual 1 degree difference make in the final answer. So why don't you go ahead and figure out the two answers with the 1 degree change, and then be thinking about how much the answer is being impacted by that 1 degree. If you think about a protractor, how much 1 degree looks like on a protractor, which isn't very much. And then turn the video back on when you have completed the problems, and maybe this will give you another way of looking at or answering the question of why don't the answers match. All right, so for 250 tangent of 72 degrees, hopefully you got an answer of 769.421 meters. So we're looking at here, approximately 48 meters difference. And 48 meters may not seem like a lot, but a meter is a little bit more than 3 feet. So if I would multiply this by 3 to turn it into feet, we're looking at approximately 144 feet. And that itself is like a 14-story building, just in a 1 degree difference. And if I was looking at going the other direction, doing the 74-degree angle, the answer is 871.853. So again, the difference between these two here is approximately 54 meters times 3, so about 162 feet. So again, a building on average is about 10 feet per story. So we're looking at about a 16-story building. So, and that's just a 1 degree difference. So you get the exact answers when there's such a change in just 1 degree. It's probably, I mean, it's highly unlikely, but we are close. Especially the problem 4, we're only off by like 3 feet, plus the distance from that person's eye to the ground. The answer 3, though, we're off by 12 meters, approximately 12 meters, and that's about 36 to 40 feet. So that's a significant difference. You get about 40 feet, you get a 4-story building. So angle measurement is probably the biggest change. In terms of 1 degree, can make a significant difference. All right, go ahead and move on to problem 6. I'm sorry, move on to problem 7, we're skipping 6. So this is going to be, I think, the last problem for this video. I want to keep the length on one video and the angle measurement on the second video. So this is the last length problem. The second video will be the rest of the handout. Here's a kind of drawing again. So again, we have the same issue as the previous problems in that we still don't know the distance from the person's eye height down to the ground. But again, these are approximations. If I show the two sides of the angle, it's the opposite. The hypotenuse is the unmarked side, and the adjacent is the 220. So again, we're looking at another tangent problem. The tangent of theta is equal to the opposite over adjacent. So if I plug in my numbers, so tangent of 60 degrees is equal to h over 220. Again, cross multiplying, so 220 tangent of 60 degrees is equal to 1 times h, which is h. So 220 times the tangent of 60 degrees. So the height of this tree is approximately 381.051 feet. So it's approximately 38-story building. Again, if you think about 10 feet every story. So it's a very tall tree. Another way you could have done this problem, since this is a 30-69 triangle, you could have multiplied the 220 by root 3. So height would have been 220 root 3. And if you put that into the calculator, you ended up with 381.051 also feet. So you get the same decimal number. So don't always assume you have to use trig. There's an example of a problem that actually fits into one of those special triangles.